section 6.4. This section is all about the metric system. So this is in contrast to the American measurement system that we were looking at in section 6.3. The conversion factors in the American system are kind of random. They're not super organized. Sometimes there's big jumps, sometimes there's small jumps. Regardless of if they're big or they're small, the numbers are not consistent anyway. You know, it's kind of a system built from just common usage type stuff. I mean, it sort of is a hodgepodge system, I think, that kind of just comes excuse me, comes up over a long period of time. The metric system, on the other hand, is kind of designed on purpose to be very organized. And so the sort of math system here is it's a measurement system based on powers of 10, right? This works exceptionally well with our sort of number system, because the number system is a base 10 number system, right? Meaning that there are sort of 10 unique digits, right? And as you go from like ones to tens to hundreds to thousands, right? All of those changes, right? All the sort of as you work up the digits, every time you're either sort of multiplying or dividing by 10 to sort of go up or go down. And so the metric system is designed in particular to kind of work with that number system, our number system. And rather than have different systems and sort of different conversions for length or volume or mass or whatever, everything in the metric system is organized in the exact same way. So what we're going to do, let's sort of identify first what our base units are, and we're just going to do length and volume and mass. We're just going to do essentially all of those all at the same time. So for length, the base unit is the meter. The abbreviation there is going to be M. A meter is a little bit longer than a yard. We'll be doing conversions between sort of metric units and the American system in 6.5, so we'll get into that in more detail here coming up. But the meter is the base unit, and so what we're going to get as far as bigger or smaller units from there are all going to be kind of variations on the meter. We'll go into how to get those variations here in a second. The volume unit, our base unit here, is the liter. The abbreviation there is an L. Sometimes you see it as a capital L. Sometimes you'll see it as a lowercase l. I'll probably use, I might stick with capital L for now. A liter, right? If you think of going to the 7-Eleven or whatever, and you can get a liter of soda or something, right? A pretty good sized jug of soda, right? That's a liter. And then our mass unit, our weight unit, the base unit is the gram, which is G. A gram is pretty light, actually. I think it's, the weight of a penny or something kind of like that. Mass and sort of weight is interesting, I think, in particular from, kind of a scientific perspective, right? If you're you work in a pharmacy or something, you're trying to like mix up different chemicals to make medicines or whatever, you're really working with tiny amounts, and you need to be pretty precise. So a gram, kind of makes sense. If you're an engineer and you're talking about a weight load of a bridge or something, well then you're talking about really heavy weights, and obviously a gram there wouldn't maybe be so practical. But that's why we have these unit conversions where we can scale up and scale down. So the system here, right, we sort of have those three as our base units. So that's kind of our standard for each of those situations that we're going to kind of reference. And so then to scale up or down, what we're going to do is we're going to use prefixes on the base units. And so each prefix is going to sort of scale us up or down by a power of 10. And so what I'm going to do is I'm essentially just going to make for us a big table to kind of lay this all out. So let's put our base units in the center. Right, so that'd be meters or liters or grams. And then from there, what should we do? Let's scale down first. So this is going to be as we move to the right, our units are going to get smaller and smaller. So the first prefix moving to the right here, the first prefix to make it get smaller is deci. And so the idea of prefix right is something you're attaching to the front of your word. So meter is our base unit, right? And so a decimeter is going to be abbreviated DM. And so that's going to be 1/10 the size of a meter. So this is kind of like, you know, times 1/10, I think is sort of how the book writes it, right? So it's 1/10 the size of a meter, a decimeter. It would take 10 decimeters to make 1 meter. And then that same relationship is true for liters and grams. You're going to have deciliters and decigrams. So the abbreviation there is just DM, DL, and DG. So it's 10 of those to get 1 of the base unit. If you go again, so that's going to take you from 1/10 to 1/100th. And then the prefix is centi. So this gets into probably some units that are maybe a little bit more common, right? Centimeter. A centimeter is a little bit smaller than an inch, usually if you have a ruler, right? Or a yardstick or a meter stick. You'll have kind of inches on one end and centimeters on the other. You could kind of compare them. Probably shouldn't try to talk through yawn. You can compare, right? Inches and centimeters. It's 2.5-ish centimeters, I think, per inch. Again, we're going to get into those later, what the size differences are. And the idea is that you have 100 centimeters to get to 1 meter. So if you have a meter stick, right, it's also broken down usually into 100 centimeters. Same thing here with centiliters or centigrams. And if we wanted to go one step further, break it down to 1/1000th, the prefix there is milli, right? So millimeter, right? 10 millimeters per centimeter, and then 1,000 of those to get to a meter. Milliliter, which sometimes you'll see, again, for liquids, or milligram, right, which sometimes you'll see for medicine, medicine doses sometimes, 200 milligram dose of such and such, right, kind of thing. Deci, centi, milli, I think those prefixes, I can always kind of remember them. One of the things you're going to want to do here, I think, is make yourself some sort of chart or have a table of these things all handy. If you don't memorize them right away. So deci, centi, milli, I think of in terms of decades, centuries, or like millenniums, right? So there is kind of a language way that these things all connect, right? So a decade is 10 years, right? So you have 10 of those to get back to your base. Century, right, is 100 years, so centi and century, so the centi is like 100. And then a millennium is every 1,000 years, right? So milli sort of goes with 1,000. So there is kind of a language connection there if you want to sort of use that as a way to try to remember. That's there. These units continue. We could go smaller and smaller and smaller down to like nanos and like picos and things like that, depending on what you're working with, and in different, scientific kind of areas and in your technical classes, depending on what you're doing, or even in computing kind of stuff. Oh my gosh. Excuse me. You might use those, but we're going to focus here on just sort of the first three at a time. Any of this stuff can kind of be extended in either direction. So let's go bigger now. So what's bigger than a meter? 10 times bigger is what we call a decameter. Not super different from deci, sad to say. We can't use D again because we have it. So what the book does is DA. So deca, so decameter, decaliter, decagram. So that's 10 times larger. So if we move this direction, the size of the units are getting bigger and bigger and bigger. So deca is 10 times whatever your base unit is. So a decaliter is 10 liters, a decameter is 10 meters, and so on and so forth. If we go up another 10, we're going to get to hecto. We'll use H, so a hectometer, a hectoliter, or a hectogram. So 100 meters are needed to sort of get to a hectometer, 100 liters to get to a hectoliter, right? It's 100 times bigger than the base unit. And then we'll go one more time up to 1,000 times, and that's going to be kilo. So kilometer, right, aka kilometer, right, is kind of on the same scale as a mile. A kilometer is shorter than a mile. It's 0.6 something miles, I think, something like that. But it's on that same kind of scale, right? And then a meter, of course, is sort of on the scale of a yard. So we have some kind of American units kind of in the neighborhood there. Kiloliter, that's pretty big, 1,000 bottles of soda. Or a kilogram, which if you think of, grams are only like a penny. Kilograms are closer to pounds. So these weight ones, right, are really kind of a little bit more kind of leaning towards the smaller weight units. Versus stuff, these kind of volume or these length conversions, I think, sync up and are a little more comparable to the types of American units that we were looking at before. That's the setup. I'm going to pause this video here. That's kind of the layout. So we're going to use that and then in the next video actually talk through doing some of these conversions. So how do we convert between these two? I guess what I'll sort of say as just a little bit of a lead in is, for our conversions, we're going to be multiplying or dividing by powers of 10. But what that really sort of means in practice is this amounts to really just doing a decimal shift, right? So if you're multiplying or dividing by a power of 10, all you're really doing there, because our number system is a base 10 number system, all you're doing is shifting the decimal place, right? Every time you multiply by 10, you're shifting your decimal to the right as you get bigger. If you divide by 10, every time you do that, you're shifting it to the left to get a little bit smaller. So we'll go into the examples here in the next video. So I'll see you over there.